right, students, welcome to one last part of the video when we're talking about limits, the introduction to limits. This time we'll be talking about 0 over 0 form limits. The guitar intro this time was from the rock group The Who, and that's the song Pinball Wizard. All right, so let's see. Let me show you what we mean by a 0 over 0 form limit. Okay, so what we're going to do to begin with is if you're doing a limit of a rational function, you should always start this way. You should just plug the value in. We're doing a limit as x goes to 1. So let's just go ahead and start by plugging the 1 in. So we're going to have 1 to the second minus 1 over 1 minus 1. And that's going to give us 0 over 0. And 0 over 0 is a form, and we call this an indeterminate form, okay? And what this means, it is undefined. You can't divide by 0. So certainly if you have 0 divided by 0, that's undefined. But it's kind of a special form that happens when you're looking at a rational function. What's going to happen is if you have 0 over 0, I'll put it to you this way, the limit will probably exist. Okay, now there are times when it won't exist, but what we're going to do is work with a little bit of algebra and then revisit the limit. So probably when you have a 0 over 0 limit, it's the limit's going to exist. There are times when you get 0 over 0 form and the limit still doesn't exist. Okay, so let's go ahead and let's look at what we can do on this. Basically, we're going to try to factor. You have to think about what's going to go on with factoring on this. So first of all, just kind of over at the side, a quick review of factoring. We have what we call a special kind of factoring problem that's known as a difference of two squares. And just kind of a quick, gentle reminder on this, a perfect square is a number like, 1, because 1 times 1 gives you 1, or 4, because 2 to the second gives 4, or 9, because 3 to the second gives 9. The reason we call these square numbers is actually pretty simple. If you have 4 dots, you can make 4 dots into a perfect square. If you have the number 9 and you had 9 marbles, you could actually put 9 marbles out in such a way that it would form a nice perfect square. Same thing would happen with 16 and 25 and so forth. And we call the difference, the minus sign, the subtraction sign that separates those two. X squared is also a perfect square because it's x times x. So that's just kind of going off the side and giving you a little information about this particular type of factoring problem. So when we factor this, we draw 2 parentheses. The first term is going to be x times x. We're creating a problem that you would FOIL, just multiply out, and it would give you x squared minus 1. The last term's 1, so that's 1 times 1 like that. And what happens on this is you don't have a middle term like a trinomial, so you want this inside term and this outside term to cancel. That's why you put a plus minus there. So the way that you factor a difference of two squares is like that. Okay, another real quick example, if you had x to the second minus 9, same thing. You just go x and x. 3 times 3 is 9 plus minus. FOIL it out, it'll give you what you start with. Okay, so what we're going to do is we're going to go ahead and do that factoring and then see what happens. Okay, so we factor the x squared minus 1, so we get x squared, x plus 1, x minus 1, over x minus 1 like that. Okay, well what's going to happen is that's 1. Okay, if you have x minus 1 over x minus 1, that's equal to 1. Okay, so we're just divided out. And what we'll have left with then, I like to think of canceling. I prefer to think of it as removing factors of 1. That's a good way to teach that, I think. So I'm removing a factor of 1. So I'm left with the limit, x goes to 1, of the linear function x plus 1. You're going to find when we graph this on the calculator, it's going to look like this line right here, with one tiny exception. So if it's a linear function, we plug in and we be done with it. So we do get a numerical answer on this limit of 2. So we got 0 over 0. I said the limit probably exists. Whenever you get 0 over 0, see if there's any algebraic process that you can go through that will resolve that and work that out. Okay, now I'm going to go ahead and do this on the graphing calculator and show you what happens on this. So we're going to construct a graph. I'll use the graphing calculator, but it's going to look just like the line x plus 1. So I'm going to put in parentheses, x squared minus 1, close parentheses, divide by, and then x minus 1 with parentheses like that. And make sure if you're graphing a rational function that that numerator and denominator are in their own set of parentheses. Okay, then I'll just, standard window, it looks like just like x plus 1. It's got a y-intercept of 1, it's got a slope of 1. What I'm going to do is go ahead and go to my table of values by going second table, and let's just plot a few points here. And you're going to have that error because in the original problem, you had if you plugged 1 in, you got that 0 denominator. So that's why you got that. So let's just pick out a few points and plot this then. So we have the point 0, 1. We have the point 2, 3. And what's going to happen is at this point 1, well, we're approaching 2, so we're going to go to that 1, 2, but instead of putting a solid dot, we're going to put a bubble there. And then we can connect the dots into the straight line. That's the linear function. So it's a linear function, however, it's undefined at that one particular point. That graph looks like a linear function. And again, if you go back to the first method we used on this, I could trace at a number real close to 1 on either side. I could go like 0.999, that's pretty close to 1. And notice the answer is pretty close to 2. Okay, so we didn't have to do graphing on this. We just did it algebraically. The graphing really only served as a checkpoint for us. Okay, I'll go to one more example that's similar to this. And this has got another algebraic issue in it. That's good to show students because a lot of students aren't real used to this. So let me erase some of my scribbling over here. Okay, so let's start this. You always start these problems off this way. Hey, just plug the 2 in. You're looking at the limit as x goes to 2. So we're going to do 3 times 2 to the second minus 7 times 2 plus 2 all over 2 minus 2. Numerator, work it out. That would be 3 times 4 minus 14 plus 2 over 0. And that looks like 12 minus 14 plus 2 over 0. That's 0 over 0 again. So we do get that 0 over 0 form. I put that in quotations because that's a form. It's algebraically, numerically, that's undefined. 0 over 0 is undefined. But it's a special form that will tell us something about the limit. So like I said, this probably exists. So I'm going to focus on factoring this numerator. And this is a trinomial that it's very common for students to have some struggles with factoring this type of trinomial with a number in front of the square term. So I'm going to show you a trial and error approach. I think when you're in calculus, some of you learned how to do factor by grouping. To me, it's just as easy to do trial and error. Okay, if the numbers are small, trial and error is a real good approach. So basically, when you have a trinomial, it's a result of a FOIL problem, possibly, with this being the first term, that being the last term, and then the negative 7t is a combination of the outer and inner. So the way I'm going to put this together is like this. The first term, there's only one possibility. 3t times t is the only possibility you're going to have. So when I draw up my 2 parentheses, I'm going to put 3t times t in either order. The last term is 2. Again, there's only one possibility, 1 times 2. So I'm just going to throw in, 2 times 1 like that, and I'm going to show you what happens. Now, one of the keys to being good at factoring in my opinion, is not worry about the signs until the very end. Just look at this, okay? That inside term, 2 times t is 2t, so write it down on your paper. The outside term is 3t times 1. Write it down on your paper. And then you know that when you add those, they need to add up to negative 7t. So what's going to happen on this is there's no way to get this to. Okay, so we just scratch that idea. And we're not going to make 2 and 3 add up to 7. But what you want to do is don't forget that the order often makes a difference. So I'm going to start off the same way, and I'm going to say 3t and t, but this time instead of saying 2 and 1, I'm going to go 1 and 2, and I'm going to start over again. Okay, little practice, you can just kind of write the numbers on your paper and do it a little bit more in your head. Okay, write down this visual. This is very important. The inner term is 1t. The outer term, 3 times 2 gives 6t. Write the bar. What are you after? You're after negative 7t. So yeah, now can we make 1 and 6 add up to negative 7? Of course we can. If 1 and 6 are both negative numbers, then we know that's going to work out. So this thing does factor. And if you go through and do all of the steps from FOIL on this, and I think anytime you factor anything, you got the power to tell you're right. Just find out if you're right. First term, 3 times t. 3t the second. We know that. Outside term, 3t times negative 2, negative 6t. Inside term, negative 1 times t, negative 1t. Last term, negative 1 times negative 2, positive 2. You got the combination of the outer and inner, and you're back to where you began. You got the power. Take advantage of your superpower. All right, so what I'm going to do here is we'll go through and we'll factor this now. So we're going to do the limit as t approaches 2 and factor that. Numerator is 3t minus 1, t minus 2, and then we're over 2 minus t like that. Okay, so I'm going to erase the stuff I did on the factoring. You can always take snapshots and pause the video anytime you want to, but just kind of, I want to discuss one more thing about this problem and discuss it in enough detail so you'll remember how to approach this when it comes up. So the thing that you see happening on this is these factors right here. Now this time we have this situation. We have t minus 2 over 2 minus t. And that's not 1. That is not equal to 1. They don't cancel out the way you're kind of taught on that. There's a couple of ways you can learn to handle this. I want to show you, just first of all, a move that you can make algebraically. One thing you can do is you can turn one of them around, but you have to be cautious about the way you do that. So I could leave the t minus 2 alone, and I could turn this one around, but I got to keep from changing the problem. If I just turn it around, now it is 1, okay? But I need to put a negative there to keep from changing the problem. Convince yourself of why that's right. You know, if you distribute that, that would be a negative t, and a negative negative 2 is a positive 2, and that is the same thing as 2 minus t. So that's one approach you can do. So over here, I'm going to go ahead and finish the problem up, and then I'll discuss another approach that you can take. Okay, so I'm just going to bring down the 3t minus 1. I'm going to leave the t minus 2 alone. And then I'm going to do what I showed you over at the side of the paper here. So that's t minus 2. And now this is negative 1, t minus 2. Okay, so what happens now is this is 1. This thing right there is 1. So it divides out. You're removing the 1. You can remove 1 from multiplying anything, because if you multiply 1 by anything, it's that same thing anyway, if that makes any sense. Kind of sounded weird the way I said that. But what you're going to end up having here is the limit of, as t goes to 2, of 3t minus 1 over negative 1. Now, you can plug in and see what happens. So let's see what happens. We get 3 times 2 minus 1 over negative 1. That's 6 minus 1 over negative 1. That's 5 over negative 1, so that's negative 5. So the answer to the problem appears to be negative 5. Okay, so that problem's a little more complex to students because of the factoring in the numerator with the trial and error, but also that fact that you have backwards factors that are being subtracted. Now, I do want to take the opportunity to go through this a little more in detail, just on a couple of things, because this will pop up from time to time. So if you had t plus 2 over 2 plus t, that is equal to 1, because they're the same, okay? I mean, you can add backwards. All right, so the thing is, that really is the same of that. So if anytime you see that, that is 1. But if you see this situation, t minus 2, t minus 2, that is not equal to 1. So you have to adjust that by doing this. Okay, now notice that crosses out, and you're left with negative 1. You're just left with that negative left over, so it's negative 1. Okay? Another thing that's worth noting on this is if you had something like 5 plus 2 over 2 plus 5, that's 7 over 7, that's equal to 1. So it doesn't matter what order you add things in. But it does matter on subtraction. So if you had 5 minus 3 over 3 minus 5, well, that is 2 over negative 2. So that's negative 1. So you can learn to handle this situation this way. If you saw that you had x minus 10 over 10 minus x, that's negative 1. Okay? So when you cancel that out, you're not removing 1, you're removing a negative 1. So that negative is left over. Okay? Hope that helps a little bit. Okay, so I'm going to go ahead and have you pause the video and work these two problems out. Oh, I do want to do the graph on this one on the calculator also. So let's go ahead and do that on the calculator, just to kind of verify your answer. And again, you're going to see a line on this. So we'll graph the original. So we have 3x to the second minus 7x and plus 2. And then divide by, and then the denominator we have 2 minus x. Okay, so we want to get that put in. And then you want to go ahead and just zoom 6. And then we'll check it on here. So again, you got a line. And we're approaching 2. We're doing the limit as x approaches 2. So if I was to trace a number real close to 2, like 1.99, well, you can see the graph is closing in. The y value is closing in on the function value negative 5. Okay, so that's right. You have the power, the superpower to tell you're right on any limit you do. Just get your calculator out. But don't do everything with a calculator, because then you're not learning the concept of a limit with the algebra and the other processes we're talking about. Okay, so sketch a graph. Let's pick a couple of points. Okay, you got the error at 2. And just go ahead and plot that out. So let's see, we have a point 1, negative 2. When x is 2, you're going to go down to 5. So you'll have 2, 5, negative 5, have a bubble, and then you can connect the dots like that. It's kind of a crappy graph, but it kind of just plot a couple of points and make sure you have that bubble at 2, negative 5, because when x approaches 2, y is approaching negative 5. Okay, now go ahead and pause the video, if you will, and work these two problems out. And then when you're ready to check, resume the video. Okay, so resuming. I hope that you got these answers, and I hope you did work these out yourself. That's a real important part of the aspect of the videos I make, is your opportunity to pause and check your learning. Okay? All right, if you just watch me all the time, that's not enough. That only gets you started learning. Okay, so number 1 was 4. When you plugged in the 3, you would have got 0 over 0. And then the factoring of the numerator was x minus 3x plus 1. Okay, you got to make sure you did your factoring correctly. Then you can remove the factor of 1. So you're left with the limit of x plus 1 as x approaches 3. X plus 1 is a linear function. So plug the 3 in, you got 4. Check it on your calculator if you choose to. Number 2, when you evaluate at -4, and do your arithmetic correctly, hopefully you get 0 over 0. Factor the numerator, that is a difference of 2 squares, so that factored is x plus 4, x minus 4. And again, x plus 4 and x plus 4, those are the same number. That's 1. Remove the factor of 1. You're going to be left with x minus 4. Then plug that in, and you got it. So x is equal to -8. Okay, so I hope you enjoyed the video. Hope that helped you to learn. Hope you enjoyed the Pinball Wizard introduction. All right, cheers.